Okay.
Okay, we're good now.
Okay. Okay. Hi, everybody. Okay. So, ML field is developing rapidly. There are always something new coming like every hour. You think like somebody publish a code and you think, oh man, that's crazy. This is the state of the art. And within like next hour or next week, something new comes up. And this technique is already old. Also, there's one more aspect that a lot of people from different fields starting to come to ML, and they bring their own knowledge, they bring their own habits, they bring the way how they want to organize their projects, and it seems pretty chaotic. So my talk today is kind of the title is A Tale of Code and Chaos: How to Tame Your ML Project. Basically, how you can navigate your ML project, how to organize, how to approach it. Okay, so just briefly, very briefly about me, right? So I used to be a biologist, and then I switched to be ML engineer in SciComp over the COVID. And then, obviously COVID happened and I had a lot of time to think what I want to do. And I decided to, after some time, I left Janelia. And now I work at a startup where I lead small group of ML engineers, and we try to apply, all kinds of new ML techniques to our problems. And so this is my professional thing, right? Professional life. I'm happy with that. There is, beside this, I am also kind of a top 50 ranked Kaggle in the world. And people who are not familiar with Kaggle, it's a website where kind of companies puts their hardest problems for anybody in the world to solve them. And during this time, I have kind of addressed countless challenges, in diverse sectors such as banking, medicine, chemistry, physics, very specialized physics. I don't know, like detecting gravitational waves and neutrino stuff and so on. And in each of these challenges, we were able to develop cutting edge solution, ML solution within span of 2-3 months. And often these solutions beat the expert solution or people who've been working in the field for 10 or 20 years. And one insight that I've gained from my professional journey and kind of observing people in the industry, also on the Kaggle, also in academia, is that the specialized expertise is not always important. What's important is how you kind of approach and solve the problem. And there is these two elements that are really important to solve kind of any problem. First is you need to have a framework or a certain kind of structure that provides you with enough flexibility to pose queries and receive feedback. And second is you need to have some way of organizing your observation, and you need to kind of analyze them and quickly refer to them and make conclusions. So these are two very important things that are kind of needed for any successful project, at least in my experience. And ideally, if you're doing ML or any kind of experiments, 99% of the time we should spend worrying about these two things. We should not worry about, for example, how to organize Python project, or it seems very controversial, but I will show you some real life examples that code quality doesn't matter, documentation doesn't matter. Yeah, you should not worry about this. You should not worry, for example, about writing training loops or like writing packages which will track your experiments. These are kind of not so important. And why these are not important? Because this ML community grows rapidly, and there are a lot of tools available which kind of try to solve this particular problem. For example, there's PyTorch Lightning, there's Hugging Face Accelerate, there's FastAI, there's a bunch of tracking stuff. And all these libraries are actively developed. There is hundreds of commits happening to them every day. And there is a great community, like tens of thousands of people kind of work on these libraries and use them every day. So this is what I'm going to talk about. how we can use these libraries to stay in this, within these two things, like focus 99% of the time, 99% of the time performing ML experiment and getting rapid results. And please feel free to interrupt and ask questions. Let's have kind of discussion rather than me talking about stuff. Okay, so let's look at the cycle of ML project, right? So for example, when ML project get published, like for example, this is the project from Facebook, it's called Segment Anything. It was published recently. It's basically a cool idea that you can segment anything. It's literally, you can segment anything. It doesn't matter what it is. And usually when Facebook this is published by Facebook, they make a repo. And this repo is kind of pretty chaotic. It has notebooks, and then it has a bunch of scripts, There is not so much focus on documentation or describing how this approach works. It's just collection of the scripts. And the reason they do this is because anybody can go, for example, I can just actually clone this repo, or I can just copy paste the definition of the model. I can download the weights, and that's pretty much it. I can do whatever I want. And this is kind of normal. 99% of ML projects which get published, they publish in this form. And this is the repo in a kind of in a good side. There are much worse repo where people just put their code and link to their weights. So yeah, so the reason they do so, we can basically hack it. And for example, today morning, I saw Konstantin, right? He tweeted that he kind of took this repo and adapted for, for like doing the segment anything for, biological data. So this is kind of normal things. People put the things out, they don't care about quality so much, and other people will just come and hack. So this is expected. So therefore, people don't spend so much time on thinking about other stuff. Now, this is the final product. There is one phase, which is a huge area, which happens before you publish the repo. And it usually starts on a private computer, or if you're a little bit organized, you might start a GitHub repo. You start from the scratch, you have data, and then you have objective, and you start doing a bunch of experiments, right? And these experiments kind of grow really fast. Sometimes your idea fails, sometimes not. And then eventually you might get this repo, right? And these things can get crazy really, really fast, right? So in my, this is just example, you have a bunch of notebooks, you have a bunch of scripts, and they are not usually so organized. And this is a normal space. Like we all have this kind of repos where we have our old code, which we reuse it. Sometimes it's not documented and so on. And it's a safe space, right? It's a space where nobody looks at us and we can do our things. It's like, and we are really effective. Nobody's judging us. And there is no documentation or any kind of style. And one example of these things that there is no documentation or any style, I can give you example of there's a person, it's a really famous person called Andrej Karpathy. He is a director, he used to be director of AI at Tesla and now works at OpenAI. And he recently published a repo called NanoGPT, basically reproducing GPT, right? And if you go to his training code, right, it doesn't follow any standard Python practices. So for example, everything is in one file. There are variables, and then he create configurations using globals. There is basically, there is a while loop. So the script basically runs forever and you have to stop it. So it kind of breaks the norm. And this is normal, and people do this in ML because, yeah, it's easy. And, you might have this train.py, he might have like 200 of those train.py. And, he might just, every of them will be just one modification of the layer. And, people do this and it's accepted. I know it's a little bit rebellious, but this is kind of accepted fact in the community that there is basically no standards. And everybody can have opinion about that, right? Some people don't like that, other people like that. But the reason this happens, that we do this kind of stuff, it's because we kind of want to focus 99% of the time doing experiment and getting results. That's it. You know, anything which is not doing this, it's a distraction. So today, what I decided to do, I will kind of try to walk through how we can structure our project in a way that we can focus on doing this, being in this experimental phase. And so usually any ML project can be divided into 3 phases, right? There is init phase, where we were given data, and we were given data, and we start building, you know, we start exploring the data and building our first model. Then there is a training phase where, you know, we take this model, we take our data set, and we try to train, and then usually there's experiment tracking thing. And this can happen like many, many times. Sometimes you run hundreds of experiments. So let's start with phase. So usually init phase starts with, yeah, we're given data set and we have kind of 2 choices. Or people prefer to do 2 things, right? For example, I will open IPython notebook and I will start exploring data, and then, you know, as I go, I might have some code, and I will, you know, the notebooks can get really, really big, really, really messy, right? Then what I will do that I will take this code and I will copy it to my .py static environment. I will have .py script. There are also other people who actually don't go this approach, notebook approach, but they start with, you know, properly organized static .py files, and they will write their code. And then sometimes when they kind of need something, they will go to the IPython environment and quickly dynamically test some stuff. And, you know, there's this drift, always there's this just drift between this IPython notebooks and .py. And this drift is also present in the community. For example, if you look at the recent JupyterCon talks, there's like 2 talks which are completely opposite. One is from you know, Jill Gruss. He says that he loves notebooks. And then second is from Jeremy Howard, who's also kind of big name in the field. And Jill Gruss says he doesn't like notebook, and Jeremy Howard says he loves notebook, right? And there's always this thing, this fight, like if notebooks are good or notebooks are bad, it's not clear. But the fact is that notebooks are getting adopted widely. You know, some companies have their own notebooks. For example, Netflix has their own infrastructure for internal notebooks. Google has their own notebooks called Google Colab, which are currently publicly available. So notebooks are kind of everywhere. And the reason our notebooks are so good is because, you know, you get instant feedback. We can test everything, we can print immediately, and so on. But, you know, there is not a good link which can combine notebook and kind of Python files. So, you know, this is what kind of Jeremy Howard developed a library called NBDev. And this library is great. You know, it's kind of designed for ML engineers, and a lot of people, I start working with people and I start noticing a lot of people are actually using this library into the productions and so on. And the idea is pretty simple. Basically, I will show you an example how you can set up. It literally takes less than 4 minutes to set it up. But the idea is following, is that on top of the notebook, you write you know, the .py file you want to create. So for example, this will create, everything will go to dataset.py. And then as you go explore your problem, if you like something, you can just add small tag on the top of the cell called export. And at the end of the notebook, the NBDev library will basically take care of everything. It will generate dataset.py file. It will take care of the scopes of the variables. It will export everything following the best standard, you know, best Python practices. And I can show you some projects. So, you know, one thing I decided for this talk is to actually, you know, when people usually give this kind of talk, it's really abstract. So what I decided, I'm going to show you some projects which I work here in Janelia, how I use these libraries, you know, with the tools which, you know, people in Janelia use, like Gunpowder, like all this kind of like data loading, ZAR, and so on. So, you know, when I was in a Zalfit lab, I worked on the project called Stardust, Stardust Torch, right? So this was ML projects. The idea was I don't remember exactly what was the idea, but we wanted to apply studies to the, cryo-EM data or something. And, this was very new. I never heard about study storage. So what I did, I used NBDev. I created my kind of notebook, right? So I was given data, and then I start exploring, right? I wanted to understand how Stardust works, right? So obviously I wrote, for example, where my files should go, and I start exploring, right? How Stardust works, for example, and it was 3 years ago, right? So I yesterday revisited everything. So, I wrote for myself. I was doing this for myself, right? So just to understand how things work, right? So we have image, we have mask, and this mask is used to predict distances. We use this mask to generate probabilities and so on. And, I was developing in this notebook environment. And as I went, I will plot stuff. I will also kind of do tests on these notebooks. When I was creating functions, I will do tests on these notebooks because it was just convenient. And you will see it's, when I say there's a lot of people who actually do this kind of things. And having tests for ML, it's actually very rarely happens. Usually people just check the shapes, but in regards, it's the other topic, right? So if I like something, I will just write export, right? And these notebooks get really, really complicated, really, really fast. And I have like 25 different versions of data sets. And the cool thing is that as I go, I was just modifying them. And every time at the end, what will happening is that everything was getting exported to, everybody can see my screen, right? Yeah, okay. So everything was getting exported to, I will share you, to this called Stardust Storage Library and to this data set folder, right? And this is everything what I wanted to explore. Again, it's a bit chaotic. There is no kind of style. Because this was not the purpose. The purpose was to fastly prototype and develop something which is working. And I did this for everything. So I have this notebook for metrics. It's a small notebook, but there's notebooks for inference code and so on. And in fact, there was other project beside this. There was a project. Let me go. Sorry, not GitHub. It's called SlabMe. It was working with Jan Funke and Stefan Zalfeld also, yes, to find the surfaces of the things. And again, I started exactly the same. I created notebooks, and you just go, because you want to have really fast feedback, right? And you want to test things exactly on the notebook environment. And I created these long notebooks and like different versions of the stuff, and it was all exporting here to the data set.
Habib, quick question.
Yeah.
Have you ever tried reactive notebooks? Like I
No.
think there's something called iPyFlow.
No, I haven't.
Okay.
This is first time I'm hearing it about them. But yeah, I will. Yeah, maybe you can tell me what's the difference? Like, is this similar concept?
Yeah, I mean, it's basically like a mod to Jupyter Notebook. The only difference is that as you update cells, it will update dependent cells automatically, or maybe with a simple keystroke. So it's a little bit easier to keep track of the state of the notebook, which is my main critique of notebooks in general.
Yeah, I will check out. Sounds interesting. So my point here is being that, using Jupyter Notebooks and this NBDev library, it allowed me to focus on things that matter and not to worry about things that don't matter. Okay. So this is one thing. So I can also show you how fast it is to set up project with NBDev, right? Just quick demo, right? So it will take less than, I will show you, it will take less than 3 minutes to set up. So we go to NBDev template. There's many ways to create this, right? I usually like to go to template. So they have this new version of it. And then you do this, create a new repo, right? And then let's say Janelia test, right? Oh, sorry, I will do it here, G test. And so, yeah, so it will generate the repo. And then what you have to do, it's actually only a few things. You take this and then let me go to my VS Code. So here's my VS Code. So I will just git clone it. I will make it slightly bigger. I just want to point out that, these things are really fast. And so it's cloned, right? So this is the repo, right? The only thing which you have to do is go to this setting any, and you call, so this is the only, I actually only visit once during the start. You just give it library name. Let's call it gtest. And the second thing is you have to give it where your notebooks will be, right? And that's it. And there is a bunch of things, right? I will explain what happens under the hood. So, I save it. Then you go here, create new folder, create notebooks, right? And then you go here, create new file, and then let's call it dataset, right? .py, .ipython notebook. And right, and then let me just copy paste some stuff, right? So I just do things faster, right? So the first thing is that we need to write on the top what we want to export to, right? This will be the, forgot about that. So we're choosing this thing, right? And then you just write what you, sorry, export. Yeah, and you can start exporting that. So import NumPy, SMP, and then you can go and do whatever you want. And if you like something, you can just export, right? So for example, we can say good luck, and you do pass, right? And then export, and then you say convert everything to script. Oh, and hopefully it will create a library. And you see it's already created. Everything got exported. And it took like less than 2 minutes to get started, and it's very interactive, right? So NBDev is great, right? So I only use 1% of NBDev. I just only use this, for this quickly dynamic prototyping, but actually it does a lot of things. So for example, people use it. It has GitHub Action integration. You can actually, once, if you want, you can automatically create packages using Anaconda or PyPy. It's actually one command. It's all taken care. And also, all the notebooks can get rendered to create a documentation on beautiful websites. And actually, some people use it as a journal, lab journal to track their progress and so on. It's a great library. Okay, so we're in the phase where we started the project, right? So let me move here. So we are this init phase. If you're using notebooks, you can use these notebooks, or if you're using kind of, .py or Python style, it doesn't matter, right? Let's say we are in init phase, and usually the outcome of this init phase is having two things. One is datasets which returns piece of your data, and then you have your first model, right? There is these two things, right? And then there is, after this, the training phase starts, right? The training phase where you kind of combine your data set with the model. And training is something very simple. Basically what happens, you generate batches of data and then you apply through the model and you calculate the loss and so on. And the training loops are really simple. Well, they seem simple, right? So we can write simple training loop, but for example, if you want to modify something, let's say half precision training, you have to slightly modify the training loop. If you want to do gradient accumulation, you have to slightly modify training loop. And let's say if you want to upscale stuff, you have to kind of rewrite stuff a little bit to take care of correctly gradient accumulation, batch syncing, and so on. And the training loop is such a common thing, such a common and isolated problem that there are really three big libraries which kind of tries to solve this problem of training loops. There is FastAI, there are PyTorch Lightning, and there is Hugging Face Accelerate. Now, they kind of all do the same thing, but their approach is slightly different. Their syntax is slightly different, but the main advantage of using this library is that you pretty much can do anything with one line of the code, and you don't have to worry about the bugs because every day hundreds of people are using these libraries and it's very robust. And second thing is that this library usually don't care what is your data set source. They also don't care from where you got your model. It can be Python geometric. Your data set source can be something like gunpowder. You know, this library is the only thing which they care. The only thing they will take is data set and model, and that's it. So with fast AI, to start training, it's literally few lines of code, right? So basically what? You create your data loader, you have your model, and you create the learner object, and then you start training. That's it. And PyTorch Lightning and Accelerate, they kind of also have the same thing, right? It's only a few lines of code, and they take care of everything. You don't have to think about anything, right? And let me show you the examples of again, on the projects which I work, how easy it is to do that. So let's go to started storage, for example. Let's go to SlabMe, right? SlabMe surface finding. And this is my training loop, right? So this is once you created your data set, right? I create data loader. The difference between data sets and data loader is that data sets returns one item, data loader returns batch of the item. You have your data loader, you have your model, and you start training. That's it. And here, for example, I train on half precision, and that's it. Simple. I don't have to worry about anything. I can focus on like thinking about what to do next, but that's it. And and you can see how easy here is mix and match, right? We can test different models, different data sets relatively quickly. I can also show, so for example here, yeah.
Yeah, I had a question that down there over by the trainer, it seems like you're also doing WANDB to track some of your stuff there. Were you going to talk about like integrating those kind of libraries later?
Yeah.
Okay.
So I'm going to talk about how we can track this experiment. Yeah. And funny thing about this project is that I use gunpowder, right? Jan Funke library, right? So where is this thing? I just want to make a point that these libraries, they are very robust. They work with gunpowder or with the tools which we use in Janelia. They don't care about the source of the input. They just work and they're robust. Same thing can be done for. Let's look at the started storage. Let's look at the training loop, right? We can look at the training loop. Oh boy, there's a lot of stuff here. But the training loop, you'll see that it's kind of really, really simple. Again, you create data loaders, you have your model, and you just train. That's it. And yeah, and do whatever you want. Okay, let's come back to this, to my presentation. Okay, yeah, so, okay, 1 second. Okay, so we talked about 2 phases, right? About initializing init phase. I started with saying like, hey, look, we want to be focused 99% of our effort thinking about experiments rather than thinking about how should we perform them, right? I showed you that, we can use like, NBDev, for example, quickly create something really fast, really dirty. Then I showed you how we can, it doesn't matter what is your source of these things, how we can take this and start training. And you can see that it's really few lines of code. Now, there is a second thing is how we can track the experiments, right? So usually there are 2 solutions. One is, well, there are more solutions, but the well-known is weight and biases and Neptune ML. And they kind of all have their advantages and so on. But the cool thing about this is that all this weight and biases and Neptune, they are all integrated in these libraries. It's just one line of the code, and they will take care of everything. I also want to point out one thing, that these libraries, it's really easy to scale your training. For example, if you have like 16 or 32 GPUs, the only thing which you have to do is specify a number of GPUs, and everything will be taken care. how to correctly log, the gradients will be calculated correctly, the metric will be calculated correctly, and so on. So let's talk about experiment tracking, right? So I want to show you some project, like how the experimental tracking was done. So let's look at the Stardust projects, right? Again, let me find it. Stardust. Okay, so here's the project, right? So I worked for 4 months there, and I have done 147 experiments, right? All these experiments are recorded and tracked, right? I can look, I don't know, let's look at this experiment, right? You know, everything is there. I have my validations, you know, I guess we were working, I don't know, maybe Larissa will remember, but there were different cell lines. Yeah, basically everything is there. You know, perhaps I can, like, you know, we can find out what was the best model, all the, you know, let's look, right? You know, everything is there. I know exactly what, you know, which system I used. There is a, you know, it records the configuration you run. For example, let's try to find this configuration, right? What was this experiment about? Let's go to my GitHub, right? Let's look, let's see if I can find this. Just for fun, you know, see what happens, right? Let me look at this configuration. Oh, yep, there is this configuration. So, you know, so this has been 3 years, right? But I think I can understand what's happening here, right? So this was experiment for 100 epoch. This is the hyperparameter which we use to create the arrays. There is a source where the data was located, right? And there is which data set I use, right? And then this is a transformation I use for this experiment, right? And this is all recorded, right? So let's try to see if I can find this data set. Let me find if there is this data set exist. All right, yeah, there is this data set. Yeah, look, it's all there. And, you know, my point is that after 3 years, I have very good idea. Kind of, I can get what I did. There is a track, and it's super easy, you know? Everything is there. I don't know how many people can say this about their experiment for 3 years, but it's there, it's publicly available, and I can, you know, I can replicate this stuff. So to point how this done, so it's literally one line of the one line which you have to add. For example, you initiate your project. So this is my training group, right? And you just initiate your project and you just add a callback. It's weight and biases callback. For other libraries, it's very similar. There is also Nipton callback if you like Nipton, right? And it will start tracking everything automatically. I'm pretty sure there is also SLAB-me project here. Let me see. Let me see if I can find a surface finding project, which was done with Jan and Stefan. Again, it's a similar thing. I remember like a few months back, Konrad asked me, or Stefan or Konrad asked me to figure out, you know, they needed to figure out what was the best model. And I remember it was super easy for me to figure out because I literally went here and found it. So yeah, so this library is awesome for tracking experiment. And, you know, this project seems a little bit kind of easy, but I can show you there are much more complex projects. I tracked them. For example, Decode, right? Serene, it's slightly different training loop, but here, you know, we didn't have a metric, but what you can do, you can also upload the images, right? So during the training, for example, here, I was kind of uploading images, right? It's all recorded, you know, like to my steps, and you can go back and forth. It's attached to your run, and like you can see what's happening. So, you know, this library is really powerful. And yeah, and, you know, I hope I convince you that, you know, yeah, it's really easy to track stuff. Okay, let's come back to this. So, summary of my talk is that, look, I was I was in Janelia. I used the tools which were in Janelia, like, I don't know, Gunpowder and so on. And, I spent relatively short amount of time in the labs. And within this short amount of time, I was able to run a bunch of experiments, like 140, 200 experiments. All these experiments are recorded. I don't know what is the outcome of this, since when I left there. But my point is that, it's really important that we spend less time about thinking about how to do things. We should just, focus our time on thinking about experiments, like what experiment we should do next, and take advantage of all these open source libraries that are, present in the community. Yeah, and that's it. I hope. Yeah, if you have questions, please feel free to ask.
Thanks a lot, Habib. So I had a couple of questions just on the, you had mentioned that there were different alternatives for, let's say, like the training part or the data collection part. So from your perspective, I think you've primarily gone fast AI, weights and biases.
Mm-hmm.
And then if, looking at the current landscape right now, do you see that there are advantages maybe for either PyTorch Lightning or Hugging Face Accelerator versus fast AI?
So they're very similar. Like for the stuff which we do, I don't think it matters which one you use. But recently I start using Accelerate for training transformers because I needed to train on some quantized version, and they had a really nice integration. But then, like week after, FastAI integrated Accelerate into their backend, so you actually can. And also, the PyTorch Lightning has now Accelerate integrated into their pipeline, so there is no difference at this point.
And in terms of like weights and biases versus Neptune and things like that,
I try to use Neptune, but I just like user interface of weight and biases. But they do the same thing. It's just stylistic choice. Yeah.
Cool.
Yeah, if there is.
I have another question, Habib.
Oh, hi.
The typical project that you do, how many people do you work on one project? Do you work individually? Because I mean, I like the concept of breaking things at the same time. If you work in bigger teams on a project, everybody has their own style and their own way how to do things. How do you reconcile both with one another, or you don't have to?
We don't have to, unfortunately. And you will see that this is the case a lot in the industry, that we even try to have like proper repo. Oh, I know people, they even try to have proper repo, but what happens at the end that everybody clones the repo and they do things their own way, and then at the end they will just style it and push it. So it's like double the work. So
what happens?
I don't know
what happens when you are sort of collaborating with, because you collaborate in teams, right? To do Kaggle competitions. How do you sort of collaborate that way?
You can actually, so it's pretty much everybody forced to work on notebooks, and like you can push the notebooks with the, it has nice integration with merging and so on. This is one thing. Other than that, we send .py files like model definitions, and you just copy paste. And this, again, I'm telling you, this also happens in the industry. Like, it's just easy to send notebooks over the email or over the Slack. Yeah, yeah.
I have one more question on your concepts. Like you say that you should focus basically on the code, and I think that's how science programming usually works, right? People focus on the code, don't think so much about documentation and so on. At the same time, I don't think you'd actually do that, right? Because you have all your documentation of your experiments right there, right? Because you make sure that 2 years later you can still run them and so on and so on. So and sometimes you do worry about documentation and being reproducible just in your own way in some sense, right? So just kind of wondering how you see this, right? Because you actually, I think you do care about this, right? You seem to be, look, I can still 2 years later understand what I've done. You can only do this if you kind of really, on the top, you kind of have what I sometimes call self-explanatory code, right? You kind of put all the data there. So, I mean, in some sense, it is documentation, right? I mean, it's just don't waste too much time on it, right? Like, just have it as minimalistic as possible, right? That's the mantra, I guess.
Yeah, I think that's the correct way of doing that. Yeah, putting this, like, you know, because if you look normal documentation, it's pretty verbose. You have to declare typing and so on. Yes, it's little notes, crumbs, which we can pick up. I think I would say this is my documentation, but you're right.
I kind of, so going off of what Stefan said, looking at your workflow, it kind of reminds me a little bit too of like how people do fiction writing or creative writing, or very, very open-ended, so that you don't get tied down to anything. And so it seems like you're definitely keeping provenance, you know, so the weights and biases are telling you exactly what you did things so you can go by. But the documentation in terms of like the typing and like sort of solidifying exactly how you're doing particular bits of code, that it seems like you're really relying on the, you know, sort of the dynamism of Python, so that you can very quickly, you know, just throw things together, global versus local, whatever. You just, nothing should limit you in terms of just like quickly iterating, right?
Yeah, I think that's the idea.
So you recently just did the Ice Cube competition, right, in Kaggle, which I think you took second in the final thing. And you released a GitHub repository. Did you go back and add documentation, or is that pretty?
No, actually, all my documents. So I can show you, right? So the way I also did weight and bias is pretty much the same style, right? Yeah. So basically, again, notebooks, and these notebooks are really, really long, you know, because there is like, let me actually show you a data set, right? There is like 200, I don't know, 35 different versions of data sets, right? You know, data set V15, data set, I don't know, V13. And then what I do, and then I have one training group, right? It's just a matter of combining different models. And then look, this is my summary of what I did, right? The scripts, how to reproduce that. And pretty much that's everything I need to figure out how to do it. And I use weight and biases to track all the experiments. And
so that output of the README is coming directly from the sort of built-in tooling?
Yeah. But yeah, it uses the NBDev. It's big. Yeah, these are huge notebooks, like literally, I don't know, it's like, there's a lot of stuff happening. I test there, I like do this, and then I export it. And like, there's like many projects done like this. And actually people do like, this is it. And if I need to reproduce something, and you know, again, I want to point out, this was my experimental repo. And then you have to publish something nice, and obviously something nice is nicer, right? So you go here, right? And it's okay, it's following all the normal things, right? Look, we have some git clone, like setup, a little bit explanation, blah, blah, blah. But at the end of the day, it's, you know, it's just this, you know. And again, it's use fast AI. It's nothing you change. I just copy pasted all my experiments. I just extracted the important thing. Just did like,
I was just gonna ask, like, so I can imagine that when you're doing like all these competitions, you can at least be motivated, like in terms of what kind of score you want to get based on how other people are doing. And maybe you would have previously thought you hit some limit, and then you see someone else has like a better score, and then you realize that maybe something else is possible. I mean, I guess I was just wondering how often that happens, and what you do in the industry when you don't have other people to compete against, when you know that you've kind of hit, you know, the best, or if it's good enough, or if you can have another big jump or something.
Yeah, so in Kaggle it happens a lot. Like pretty much like every competition, you think, okay, I'm done, like nobody can beat me because I have unique idea, and like next day somebody have better idea. So yeah, so this is tough. This is tough, right? So this is maybe the reason why you get such a crazy solutions, right? In industry, yeah, it's yeah, there is no leaderboard. There is internal leaderboard, and you just do on test. And so in industry, things like 1% improvement doesn't really matter so much because people prefer. There's other things which people prefer. Is, for example, how easy to deploy the model into production, for example. You know, it's better to have like a 5 megabyte model, which can run in like 1 second. Like it can run, yeah, it can take like millions, you know, requests in 1 second rather than have like 10 megabyte model, which is slow. So,
Gotcha. Yeah, that makes sense.
yeah, so it's slightly different. Yeah. Yeah, I mean, if there's no other questions, I just want to say, like, you know, this is definitely the way how I do or how I see people do it. So maybe there are other ways. So please, I hope I didn't insult anybody. You know, there might be companies that are doing stuff differently, but to my knowledge, it's pretty chaotic what happens.
I guess one question that I had is that, and this came up in the Fast AI course a couple of times. So you've done a lot of different, you know, problems. You've used Fast AI in a lot of different, you know, problem areas. Were there time periods, or do you see that at some point Fast AI becomes kind of like a limitation? You have to drop a lot under the covers, you know, but beneath the Fast AI layer and start crafting your own solutions, or have you mostly been able to just stay completely, you know, with Fast AI?
I was able to stay with completely with Fast AI. In fact, I'm actually not using fully. I'm only using, yeah, like, I don't know, just the training loop. There is a correct way of doing stuff with Fast AI, but I'm not doing that. And yeah, most of the time I actually never needed. I don't remember where. I mean, for some transformer training, I prefer to use Agile library because it was just better integrated. But other than that, no, I don't remember writing. I don't remember writing my own.
Janelia on like geometric deep learning and those kind of topics, and I was wondering if you were doing that kind of stuff, or if Fast AI has kind of moved in, you know, supporting that.
So I used PyTorch geometric right on this neutrino challenge, and I actually didn't change it. I just used Fast AI. I mean, it just worked. I mean, you have to take care of the batches, but other than that, it works. You know. Again, you know, there are people who write their own training groups, which is fine. Like, you know, it's fine to write, but I'm not definitely one of those.
Great. I'm gonna.
But yeah, I never seen. I don't know. I've been. Yeah, you're right. I worked with Janelia. I kind of like. Yeah, never seen need to write my training group.
Mark, you had a question?
Yep. So I think you're probably right about wanting to iterate quickly and not necessarily have to deal with a lot of package organization. Although I think some of that could be addressed by using templates or something like this. So in the Python world, I see a lot of cookie cutter, for example. Right. And I think that would still satisfy your workflow requirements, right? That you don't have to think about this, but
yeah,
you have a template that you do once and then you don't think about it again.
Well, I think that's what NBDev is.
I think on one hand, right? I mean, I think it's a combination of the two. NBDev deals with like converting your notebook, your Jupyter notebook workflow into kind of a bunch of files, right? But I think cookie cutter basically does the other half of it, which is you put a bunch of things already there, so you don't have to think about them.
Well,
I think that.
Yeah, I think that at least what we saw with the NBDev stuff is that there are some magic stuff there where it does handle things under the hood because you've got support. You know, like when I think Habib, when you were looking at the creation of the data set itself, like the little directives that you're doing it. So there might be a little bit more to NBDev than just parsing it out.
Yeah,
yeah.
And again,
go ahead.
Yeah, you know, Yeah, so again, I use only 1% for NB dev, but I think, Mark, what you're saying, like, yeah, there might be different ways of doing stuff, like, which will, I think the take home message is that, maybe there are different ways of reaching this 99% focus experimental area, and it's totally fine. I think this is the biggest take home message that, if you have kind of, you can allow you to focus and take care of and forget about other stuff. I think that's more important than what tools to use, right?
Yeah, and I think the other thing you emphasize is kind of the notebook use, and I know Conrad put together this Jupyter Hub thing on our cluster, but I feel like progress kind of stalled on that a little bit. We haven't done much more with that, or maybe held a lot of tutorials on for other users in the labs to use that, and that I think that's something I've noticed that's very different at Janelia. We past institutions really push that much harder. In fact, that was the main interface by which most users actually ran HPC jobs or on the cluster, just because it's very easy. And yeah, I'm thinking maybe I should revisit that now that you bring this up. I also recall, I think, was it Philip made a remark about setting up his own Jupyter lab on it locally, and instead of using kind of the outside services, and it sounds like that might be a good idea as well.
Yeah, I like notebooks. This is the only thing I have to say here.
Yeah.